Hello, this is Jeremy, and in this video we're going to go through how to make relative frequency distributions. We're going to talk about making joint frequency distributions. All of these have their own place, and this is for a very specific type of data. Mainly we're focusing in this video on the joint distributions, where we're trying to see how two variables work together. So this is a problem from your textbook. It's number 12 out of chapter 2. And what it does is it says we surveyed a bunch of advertisers and we said, okay, how would you rate the service and when is your commercial on? And so we collected the data and we want to look at a few different things we could do with that data set. So the first thing that we're going to do is construct separate relative frequency distributions for each of the two variables. Now the two variables are the time slot and the rating, and this data is set up kind of strangely. The way it works is these go together. So in other words, we really have two tables here that are compressed. So this is one part of the data set, and the second table over here is the second part of the data set. So somebody who had a time slot of 1, which was morning, gave a rating of 2. And somebody else who had a time slot of 2, which was afternoon, gave a rating of 2. So in the same thing over here, we have a 1 rating for a time slot of 1. But when I look at separate relative frequency distributions, I'm actually not worried about how the variables move together. I'm just looking at them on their own. Now this is different from the frequency distributions we did with histograms because this variable is not continuous, meaning it can't be a range of values. So it's either 1 for a rating or 2, it can't be 1.5. So when I actually make the frequency distribution, which I have to start to do relative for rating, I'm just going to list only the possible ratings. I'm not going to try to make classes or anything like that, and then their frequencies. Okay. So ratings could be, and it said it on the initial part, and you can look in the textbook, anything from 1 through 5, but whole numbers only. So what I want to do is count how many ratings of each of these, or how many people gave each of these ratings. So for example, for 1, when I go through and see, okay, I see 1, 2, 3, 4, 5 ratings of 1. So that's the frequency. Remember, frequency is just count. Okay, ratings of 2. 1, 2, 3, 4, 5, 6, 7, 8. So I see 8 ratings of 2. Ratings of 3. 1, 2, 3, 4. Ratings of 4. 1, 2. And then so for ratings of 5, I only see 1 rating left, and that's a rating of 5. So I'm going to cross it out so I can double check everything. All right, so this is just a frequency distribution. If I asked for that, or if the question asked for that, you got it. And notice it can tell me that most of my ratings were pretty low, right? So this isn't related to the time slot anymore. This is just related to the rating. Now, what we can also do with this is what the question asks, which is a relative frequency distribution. So the relative frequency distribution would keep the rating here, but now over here I'll have relative frequency. So the ratings are still either 1, 2, 3, 4, or 5, but now what I want to do is put a percentage. What percentage of ratings were 1? But I'll write it as a decimal instead of a percentage. That's what relative frequency really means. Now, how many ratings were there? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would also be 10, so there should be 20. I'm going to double check here. 5 and 8 is 13. 13 and 4 is 17. 17, 19, and 20. Okay, so I didn't miss anything. 20 total. So to calculate the relative frequency for 1, it would be 5 out of 20. And then I also need to do 8 out of 20, 4 out of 20, 2 out of 20, and 1 out of 20. So 5 out of 20 is 1/4, which is 0.25. The next one is 8 out of 20, which is 0.4. I'll write it as 0.40 since we had 2 decimal places here to be consistent. The next one, rating 3, was 4 out of 20, so that's going to be 1/5. So that's 0.2 or 0.20. Next one's 2 out of 20. In other words, a tenth, 0.10. And then the next one's 1 out of 20, which will be 0.05. And so this would be a relative frequency distribution for the ratings. You would do the exact same thing for time slot. Time slots went from 1 through 4, so you would start out with time slot, and do 1, 2, 3, 4, and then do your frequency, and then you can find your relative frequency. So I'll just do it for rating since for time slot it's a similar idea. So this is looking at the variables separately, but sometimes we want to look at them together. So here we're going to now make a joint frequency distribution. You notice that I don't even have the work for the initial frequency distributions because they're totally unrelated. This is very different. So now what I want to do is see how these variables work together. So it doesn't matter which one I put on top and which one I put on the left, but I'm going to put one variable on top and one on the left. So I'll put rating on top. And I'll say, okay, what were the possible ratings? It was 1 through 5. All right, then over here I'm going to put time slot. That was 1 through 4. Obviously, you would want to have this problem in front of you if you were working this to keep track of what possible values the variables could have. And so now what I'm going to do is I'm going to count up how many fit in each of these cells. In other words, I'm counting up how many time slots of 1 had a rating of 1. So how many advertisers with that time slot rated us at 1? How many advertisers with the time slot of 1 rated us at 5, etc. And so this is also a type of frequency distribution because in the end, we're counting. So I'm just trying to make it look halfway decent. It's not perfect drawn on the computer, but it's good enough. Now you might even want to write the time slot here, like 1 was morning. You could write morning here. I'm just going with the way the data was set up before. Okay, so now I got to go through. I'm going to look. It doesn't matter what order I go in. I just got to make sure I count everything. So let's look at ratings of 1. All right, so I'm going to circle all ratings of 1. Ratings of 1, ratings of 1. There were quite a few. That's not good. So ratings of 1. Okay, so for ratings of 1, how many were in time slot 1? Okay, so that'd be this one. 1, 2, 3, 4, 5. It looks like all the ratings of 1 were in time slot 1. So there were no in time slot, or for ratings of 1, there were none in time slot 2, none in time slot 3, none in time slot 4. So, okay, so this is, notice we're initially seeing maybe there's a problem with whoever's in charge of time slot 1. Okay, let's look at ratings of 2 now. Ratings of 2. Okay, so there's a rating of 2. There's a rating of 2. Etc. So I'm looking for all ratings of 2. So you can see why we typically would have software doing something like this. So ratings of 2, etc. Ratings of 2, ratings of 2. Okay, I think I found all the ratings of 2. Now there's so many, we got to be really careful here. All right, so how many ratings of 2 were in time slot 1? Okay, we got 1, 2, 3, 4. So 4 of them were in time slot 1. How about time slot 2? 1, 2, 3. Okay. I see none with time slot 3. And then the last remaining one we haven't counted yet is time slot 4, rating of 2 with time slot 4. Whoops, we had one of those. Okay, so now I'm going to do the same thing with ratings of 3. Circle all the ratings of 3. So 1, 2, 3, 4, and see how these broke down. Now, ratings of 3, I don't see any for time slot 1. Let me double check. Rating of 3, rating of 3, rating of 3. None for time slot 1. I don't see any for time slot 2 either. So this would be a 0, this would be a 0. Now for time slot 3, so that'd be a 3, 3. I see 1, 2, 3. And then for 4, time slot 4, rating of 3, I see 1. Okay, so now I'm going to look for ratings of 4. Now there's so few, I'm going to try to do something different so we catch our eye. We got 1, 2 ratings of 4. And now it's easy to see, right? 1 was in time slot 4, 1 was in time slot 3. And so there were none in the others. And then finally for a rating of 5, there was only 1, and that was in time slot 3. So I would call this a rather complicated graph or complicated process. Why? We have to count very, very carefully. This is, again, as I mentioned before, why we have software do this sort of thing. It's so easy to have a mistake, very, very easy to have a mistake. And so we want to make sure that we don't have those by using software for things like this. So why make it by hand at all? Well, making it by hand once helps you really understand what the software is doing. So now I can quickly see that almost all our bad ratings were with time slot 1. And almost all our good ratings were with time slot 3. So obviously, I can start looking into the cause of this. And I couldn't see that on just the regular frequency distributions earlier. Now, let's say that I asked you to make this into a relative frequency distribution. Well, the only thing you would do now is divide by the total. So I would have the same thing, but instead of a 5 here, remember there were a total of 20? This would be 5 over 20, so 0.25. So I would put a 0.25 right here in place of the 5. This would be a 4 out of 20. So I would put 4 out of 20, which is 0.20. I put a 0.20 here. All these would be 0.00, 0.00, etc. This would be a 3 out of 20, 3 out of 20, 1 out of 20, etc. So you could also make this into a relative joint frequency distribution or a joint relative frequency distribution by doing the same kind of process we did before. Okay, so let's take a look at one other type of problem that could come up with these and another way the data might be presented. Okay, so in this particular one, we're told how the information broke down. We're not given the data set itself. So it says a survey is conducted to determine when high school students, okay, freshmen and sophomores only, prefer to study. And then we're given the breakdown of when freshmen like to study. Either it was in the afternoon or in the evening. Same thing. So we're told two variables. The variables are what level the students are. So we'll say grade. And so that would be freshman, which we could call ninth grade. Or you could have called it freshman. Both are correct. Or in sophomore, so 10th grade. Okay, and then the other variable was time they like to study. So for studying, they seem to either have been asked afternoon or evening. So we'll say afternoon or evening. So remember, what a joint frequency distribution does is allow us to see how these variables work together. So okay, so it says of the 86 freshmen surveyed, 22 preferred to study in the afternoon. Okay, so this would be 22 right here. The remainder in the evening. So how many are left over would be 86 minus 22, which is 44. And of the 10th graders, or sophomores, it says of 100 sophomores surveyed, 38 preferred to study in the afternoon and 62 in the evening. This is it. This is much nicer, right, than having to count it all up. By the way, this is much more likely the type of question I would ask on an exam instead of the previous one where there's too much risk of miscounting something. But here we can immediately see that most of the time the sophomores like to study in the evening. We could also see that up here, but now we can compare it. We can start asking about percentages and stuff like that. And later on, we'll see finding probabilities based on this and determining a lot more. So right now with a problem when it's set up like this, it may be hard to say, well, what's the use of this joint frequency distribution? You had it described in the same way up here. But in the end, this will be used for many more things as we continue to study statistics in general.